So there are a couple of questions here that I'd like to review, just that they haven't been done well traditionally. The first one is just dealing with average speed. So a person walks 5 kilometers in 52 minutes. They are picked up by their friend who drives at a speed of 38 kilometers an hour for 22 minutes. What was the average speed for the entire 72 minutes, so in the entire event? So we know that average speed is going to be equal to the distance traveled divided by time. Now, we don't really know what the total distance is yet. We know that the distance, we can list this as distance total, is going to be equal to 5 kilometers that they walked, plus the distance driven. So to calculate this part, we just need to realize that hopefully it was a constant speed, and it was. So the distance drove is equal to the velocity drove times time. The distance drove, or driven, is equal to 38 kilometers per hour times 22 minutes. Those units aren't going to work. So times 1 hour is 60 minutes. (38 times 22 divided by 60 equals 13.9 kilometers. So the distance total that was driven was 5 kilometers. That's plus 13.9 kilometers equals 18.9 kilometers. So we go back up to this question, this part of the question. Speed is equal to the distance driven, 18.9 kilometers, divided by the time it took. So we probably, the most reasonable unit is kilometers per hour. So we can put 74 minutes, but I'm going to convert just right on the bottom. So that's 18.9 kilometers divided by 74 divided by 60 equals 15.3 kilometers per hour. I only have 2 significant digits. Equals 15 kilometers per hour will be the average speed. So the general way we do this is we solve for the total distance, we divide by the total time. We have a little bit of adjusting units to make it work, but we have 15 kilometers an hour. 4.3 meters per second. The second question that I'd like to have a look at, again, that hasn't been done particularly well, are objects being shot directly up. So we have a cannonball, it's being shot directly up, and it's being shot directly up at a rate of 420 meters per second. Now we've done this with bullets, we've done it with basketballs, baseballs, footballs. So we know this is going to be velocity initial, and we know that somewheres up here it's going to stop rising, and that will take place when velocity final is equal to 0. So like we've been doing these questions, velocity initial, velocity final, acceleration, time, and distance. So velocity initial is 420 meters per second. Velocity final is 0 meters per second. I know acceleration is negative 9.81 because it's going to be gravity. I don't know time, and I don't know distance, but that is what I'm being asked to find. There is only one equation that we've been using that actually does not have time in it, and it is velocity final squared is equal to velocity initial squared plus 2AD. So we can rearrange as we're solving for d. So distance is equal to velocity final squared, take away velocity initial squared over 2 times a. So the distance will be equal to 0 squared minus 420 meters per second squared all over 2 times negative 9.81 meters per second squared. Equals negative 1,764 meters squared per second squared. Is negative 19.62 meters per second squared. So seconds squared will cancel, meters will cancel with the square. Distance is equal to 176,400, 176,400 divided by 19.62. 8,991 meters. Let's double check that work. I only have 2 significant digits. So 9 kilometers. Again, big thing is make sure you write your variables out, know what the question is implying. So because it's being shot up, I know acceleration. If it's wanting maximum height, then I know that my final velocity will be equal to